All right, guys, we are here in chapter 4.4. We're going to be doing a lot of IXL again this week. Many of you did not do them last week, so that's going to start to add up against you, unfortunately. So I did resend everybody their login information, so check your school email, and that way if you weren't able to get into IXL, you can go back and do that. What we're going to look at now is called the slope or rate of change, and those two things are actually the same thing. They're just measuring like how fast something is changing. So rate of change. So when we talk about slope in math, which you're going to do a lot as you go through algebra all the way up through calculus, slope is a huge concept that comes back at you over and over again. Basically, what it talks about in terms of a line is going to be the steepness of a line. You know, the steeper it is, the greater the slope. Then another way to think of it is going to be like the rise. How much does something go up and down over the run? So, you know, something like this has a greater slope than something like that. You can kind of think of it as the measure of the slant, the measure of the increase or the decrease. I will say, for whatever reason in math, we represent slope with the letter M. I have no idea why. But when you have a line that's going up, you're going to have a positive slope. And if it's going down from left to right, you're going to have a negative slope. So when you're talking about rise over run, if it's going up, that'll be positive. If it's going down, it's really falling rather than rising would be a better term. And then rate of change isn't really any different. It's just comparing the change of two things. Like we are doing up here, rise and run are two different things. How far up and down, how far over. So it just compares the change of one thing to the other. So you might be looking at how much does the cost go up per pound? How much does the speed go up per hour? So you're comparing two different ratios. Right now, we're going to worry about just calculating the slope for lines. Something you're going to need to know for like the rest of your math life is right here. There's that M I was talking about. This is going to be the slope formula. And I can tell you as a high school math teacher that you're going to need to know that for a zillion years. You're going to get asked that and use that over and over and over. So you have to kind of get that into your brain. Because if you think about graph paper, X is side to side. That's the run, how far across it's going. Y measures up and down. And so then Y is going to be associated with that rise that I talked about. So when we talk about rise over run, we're going to be talking about the change in the Y's over the change in the X. So you can see in this picture, for example, you read a graph like you read words from left to right. And so from this left point to the other one, we're going to call this point 1 and point 2, very creative. Slope is measuring how far up did I go, therefore the rise. And then how far over did I go to get to that line? Therefore, the run. So when you're trying to figure out how far up are you going, what is the rise, you have to find the change in the Y's, because the rise is how much did the Y values change. And in math, to find change, we use subtraction. So you can see in the formula up here that they took the second Y minus the first Y to figure out that change in Y or rise on the top. And then when you're figuring out how far over does it go, this run, you're finding, because left to right is X, you're finding the change in the X's, and again, change is measured with subtraction. So you would take the second one minus the first one, because if you're trying to figure out how much did, you know, the weight change, how much did the money change, you have to find the difference, which is subtraction. So I cannot emphasize enough how much you want to get to know this formula, and that's when we're going to be practicing the majority of the time today. And when you go to the IXL, it's called finding the slope from 2 points. So you're going to be doing the formula pretty much every single time. So let's take a look at some of these. Again, I'm going to do my work off to the side because this paper gets so busy. So it's giving me a line, and it's also giving me the points. So if I write out my points, my first point is -1, +1, 2, and the second is 3, 5. So on the graph paper, you can see they went to -1 up 2, and then 1, 2, 3 up, 1, 2, 3, 4, 5. So we're trying to figure out how far up and how far over do I have to go? So what I sometimes have my high school kids do if they're confused is just write x1, y1, x2, y2. And then when we go to use that slope formula of y2 minus y1 over x2 minus x1, you can have that right in front of you and say, okay, I need to take this y2 minus y1 over my x2, and now it gets a little confusing, minus my x1. But the subtraction comes from the formula, but then I have a negative. So you have to really think about that. On the top, 5 minus 2 will be a 3. On the bottom, minus a negative becomes addition, like we learned way back in previous chapters, and we got a 4, 3 plus 1. So when you're done, you would say the slope of that line is 3/4. And so the other thing that tells you is if you're trying to get from point 1 to point 2, because this is positive, you would move up 3 over, keeping in mind that that would be to the right, 4. So see if that works. You start here, you go up 1, 2, 3, over 1, 2, 3, 4. And sure enough, you land on that other point. So 3/4 is the slope of that line. How about here? I have a 1, 4, and then I'm getting to 3, negative 2. So at 1, 1, 2, 3, 4, 1, 2, 3, negative 2. That's my line. Now notice here, I'm actually going to have to go down and then over. So I'm expecting a negative slope right here. Let's go ahead and say, all right, I'm going to say x1, y1, x2, y2. My formula is y2 minus y1 over x2 minus x1. Now think about that. Negative 2 minus 4 more is negative 6. On the bottom, 3 minus 1 is 2. And then I always simplify my answer. So in this case, I get a negative 3. So that's kind of confusing because it's not a fraction. But if you think any whole number is going to be negative 3 over 1. So if you started at point 1 like we have to do and counted down 1, 2, 3, and I'm going down because it's negative, and then over 1, you should land on the line. Down 1, 2, 3, over 1. So negative 3 is indeed my slope. All right, let's do a couple practice problems. I would stop the video and try it yourself, but if you're still confused, you can certainly watch me. All I'm going to be doing is going through and using my formula. So y2 minus y1 over x2 minus x1. Now this gets really tricky with all those negatives, so be cautious. Use your calculator if you need to. This will turn into addition, so a 2. This will turn into adding, but I'm adding a negative 2 plus 3, so I only get a 1. So this one, when I simplify it, would have a slope value of just 2. Here, when I go to use my formula, y2 minus y1 over x2 minus x1. So I'm just using my formula. Then I get my calculator and my brain rolling. I'm going to get a negative 5 here. This will turn to adding, and I actually get 11. So that's just like a weird, messy number, but that's okay. It just means that if I were graphing this one, I would start at my first point. I would have to go down 5 and then over 11 to get to the other point. They're not always going to be pretty numbers like 2s and 3s. Sometimes you have to go farther to get to those points. Okay, now there's a couple weird exceptions, so let's look at those before we call it a day. I'm going to do the same thing. I've got my point 1 and my point 2. So from 2, 5 to negative 4, 5. I'm going to set up, I like to just kind of keep track. This is x1, y1, x2, y2. So my formula is y2 minus y1 over x2 minus x1. And I get 0 over negative 6, which is really confusing. But if you do that on your calculator, you're just going to get 0. That will happen, my friends. And keep this in mind. Write it into your notes. Every time you have a horizontal line. horizontal lines go straight across from left to right like the horizon does. So you can see in this picture when they plotted the point, positive 2, 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 1, 2, 3, 4, 5. When you connect those two dots, you get a horizontal line. So I would have known without doing the math that that gives me a slope of 0. But just be prepared for those. Then here's the other weird exception. If I have these 2 points, just going in to do my homework, or excuse me, going in to do my formula, I would have my x1, y1, x2, y2, using my formula, y2 minus y1 over x2 minus x1. Now this one turns out a little more weird because this becomes addition and I get a 5. 4 minus 4 gives me a 0, and now if you try to do this on your calculator, you're going to get an error because you can't divide by 0. So from this day forward, you have to know that that means the slope is what we call undefined. It doesn't have a steepness measurement. It doesn't have a slant because if you take a look at this line, it is going to be a vertical line. So you have to kind of get into your brain that a horizontal line is going to have a slope of 0 and a vertical line is going to have a slope that we say is undefined. And those are going to be 2 exceptions, and that's a battle for everyone. Even in high school, I'm always having to remind people because those weird exceptions come up. So if I had plotted my points at 1, 2, 3, 4, negative 2, and 4, 1, 2, 3, and connected them, then you can see from the graph that it's a vertical line. So those 2 exceptions, you kind of want to make sure that you are going to highlight in your notes and keep in mind because those pop up and they're sort of rare. So then people tend to get a little bit confused. So we're going to go ahead and stop after this because this is what you're going to need to know in order to be successful on your homework today. So if you want to stop the video and practice yourself, you can. Otherwise, I'm just going to go ahead and do my y2 minus y1 over x2 minus x1. I end up with 5 over 0, so that's undefined. And it says here in the instructions to classify. All that's asking me to do is to say, hey, this has an undefined slope. And so then the type of line that that would be is vertical. That's what they mean by classify. Say what kind of line it is. Is it a regular old slanted line, vertical, or horizontal? Let's do this last one together and then I'll cut you loose. y2 minus y1, x2 minus x1, I get 0 over 7. When I do that into my calculator, I straight up get 0. And then I check back in my notes and I say, okay, well, that is what happens when I have a horizontal line. Because keep in mind, when you're doing slope, you're measuring the steepness. Well, a line that goes straight across has a steepness or slant of nothing. And if I had a vertical line, I don't really know how to describe that. It's just like straight up and down. And so that's the one that has the slope that is undefined. So you don't need to know the rest of the rate of change right now. You're just going to be able to go and do your IXL. It is under the 8th grade tab, and it's Y2. It's called slope from 2 points. So you'll be working out the equation and then typing in your answer. So when you type in your answers, write them as a half. So write them as a fraction. If you get a fraction, so say your slope is 3 over 2, you'll just type in 3/2. But if you get a whole number like 5, you will obviously just enter 5. Good luck, have a great day, and I will talk to you tomorrow. Bye.